It's my pleasure to introduce our next speaker. She's also the last speaker of the morning session, Karime Pereida. She's a machine learning and controls researcher at Ocado Technology. Karime obtained her PhD from the University of Toronto. She was a member of the Dynamic Systems Lab led by Professor Schoellig, and Karime has been conducting research to enable robots reliably fulfill tasks in unknown and dynamic environments. I'm looking forward to hear her experience at Ocado, in particular using simulation to develop industrial productions. Karime, please take it away.
Hi, good morning. Thank you for having me. So my name is Karime and I work at Ocado Technology as a machine learning and controls researcher. And today I'm going to be telling you about how we use simulation in order to develop our different products and how we have taken reinforcement learning from simulation to production. So first I want to start with who are we at Ocado Technology. At Ocado, we are pioneering the future of online grocery through cutting-edge technology and serial innovation. And how we do this is we are tackling the toughest technological challenges of our age. We build and support the Ocado Smart Platform, which is an end-to-end integrated platform that enables the world's most innovative and forward-thinking retailers to offer the best customer experience and benefit from unmatched economic returns offered by the automation technology. We use technologies from many different engineering fields, such as automation, robotics, artificial intelligence, machine learning, data science, and more. And these capabilities enable us to have amazing outcomes, such as delivering fresher food, greater convenience and choice for our customers, lower rates of food waste, all in a business model that offers the best economic returns for our partners. Ocado is present in many parts of the world. So we have Ocado.com in the UK, Morrisons in the UK too, Casino in France, Sobeys in Canada, ICRA in Sweden, Kroger in the US, where the closest warehouse that we call CFC is located outside of Washington from where we are. We also have Bonpro in Catalonia, Coles in Australia, Aeon in Japan, Alcampo in Spain, and Ofen in Poland. I don't know if some of you may be familiar with some of these brands. So what is the Ocado Smart Platform? The Ocado Smart Platform is the most advanced e-commerce logistics and fulfillment platform for groceries in the world. And it's an end-to-end suite e-commerce fulfillment and logistics solution that leverages the advanced technologies of robotics and artificial intelligence and provides our retail partners with an end-to-end solution for e-commerce fulfillment, logistics, and supply chain that is centered around efficiency and productivity, whilst creating unrivaled experiences for their customers in the region. In order to create the Ocado Smart Platform, we leverage simulation, modeling, and digital twins. At Ocado, we view simulations as a tool in order to help us test the economic reliability of our systems, to see if it makes economic sense for us. We also use it to test new hardware quickly. Sometimes we don't even need to acquire the hardware in order to test our solutions. The simulations, we also use them to benchmark algorithms, whether it's algorithms that we see in state of the art from conferences such as ICRA, or algorithms that our engineers develop. It's also the first step into assessing the quality of integration of a system. In order to use simulations, we ask 3 different questions. The first one is, what is the task that we want to simulate? At Ocado, we can have different robotic tasks. For example, picking and placing of our groceries. The second question that we ask ourselves is, what features do we need to simulate in order for the simulation to work best for us and to be able to transfer it to the real world? And finally, how do we leverage the simulation so that it works best for us, and what outcomes we want to see from it? And I'm going to tell you about the 3 different products and how we use simulation in the 3 different ways. So, as I told you, Ocado delivers groceries. And in order to do this, we have big fulfillment centers, which are warehouses that are arranged in the following configuration. As you can see, we have different totes that contain product that we sell. It could be, for example, anything that you can find in the grocery store. Apples or toilet paper and the different things come in these boxes, and they are arranged in something that we call the hive, which is this 3-dimensional arrangement of the boxes that go from inbound, so the product that is coming in. We also have some picking stations where the different groceries get fulfilled into the grocery bags to be delivered to the customers. We have the actual outbound part where the groceries go out to be delivered to the customers. And we have bagging where we put the bags into our totes. And so for the totes to move around the hive, what they have is they get the help from our bots. The bots go whooshing around the hive, and they pick up the different totes at the different locations and take them to the stations that they have to be in. If more product is coming in, they have to go to the inbound. If we want different products to be picked up, the robots take the different totes to the picking stations or to the outbound. And so in order to develop this product, you can imagine that we have to solve a very complicated motion planning algorithm, because we have thousands of robots swooshing around the hive and they have to cooperate in order to take the totes to where they need to go. So what is the task that we want to simulate here? Well, we have 2 different things that we want to simulate. The first one is that we want to simulate the behavior of the hive. What product comes in, what product goes out, what product we want to pick up at this current moment. And the second one, we want to be able to simulate the bots that swoosh around the hive. So what features do we need from our simulation? As I said before, we need the overall behavior of the hive, how the product moves and how we want it to move. And the second one is that we want to evolve through time thousands of robots that are traveling in the hive. As you can see from this simulation, the hive is not a tiny hive that I showed you in the last slide. It's a very big warehouse where thousands of robots cooperate. And as you can see, so it's a 3-dimensional array, so some of the totes have to go down and then picked up by our robots and taken to the different stations. So this is a very complex problem. As the robots move, they become obstacles for other robots. There, for example, our warehouses, they have columns like the ones you can see on the side of the room. So they are obstacles for our robots, and they have to be able to, avoid collision. So how do we leverage simulation in this context? I'm going to show you now a little video about the hive, and how we can achieve this is because of the power of simulation. Our problem, as I described, is very complex. We have all these robots that have to move around and cooperate in order to deliver groceries for our customers. And as you can imagine, robotics is here. If we wanted to just deploy an algorithm into the wild in here, it would be very chaotic. We really need guarantees that our planning algorithms will work here, because it would be a disaster to just deploy something here. So as you can see, what the robots can achieve here is the simulation have enabled us to develop the most automated warehouses of their kind in the world. We are also able to plan for thousands of robots to collaborate and pick typically around a 50-item order in 5 minutes or less. So imagine going to the grocery store and trying to pick up yourself 50 items in 5 minutes or less. And finally, and I think this is one of the most interesting things that I learned when I joined Ocado, is that the robots are able to travel at speeds of up to 4 meters per second with a clearance of only 5 millimeters between them. And I think if we look at the video, you can see some instances where this happens, where the robots just move around, and the clearance is very little between the different robots. So this is kind of like a success story, how we have used simulations to develop some of our products. The next product I want to tell you about is it's actually a new product that we recently launched, I think in the past few weeks, and we call it the Induct machine. So for those who are not familiar with the term, induction in the industry terms is basically when you have a bunch of objects, the process of identifying an item, picking it, and then deciding how to handle it. In the context of, for example, delivery of things that we buy online, this may mean the objects come into some part of the machine. We then identify key products, and then we decide what to do with them, where they have to go next in the warehouse process in order to go to your houses. And so what is the task that we want to simulate? I'm going to show you what we mean by induction. So we have different, in this case, different boxes, and what we need the robots to do is to identify some of the boxes, pick them up, scan them so that we can detect the barcode, and then place them into this belt that goes around. I know this is a very fast video, so maybe I can replay it for you to see again. So they have to be placed in this belt that goes down here, and it's a very complex problem. So how we use simulation for this robotic manipulation at Ocado. What we have to think what features we need to simulate. But here's where I really, the sim to real gap starts to show. So first I'm gonna play you the video on the left, which shows the simulated environment of the input. And as you can see, the robots are able to identify one of the items, pick them up, and place them into this moving belt. But if you pay attention, the robots are able to really grasp every single item firmly. It's a very stable grasp. But in reality, what we have is, if we have a box, these are some of the easier items. We're able to still have a very firm grasp on the things that we're trying to pick up. But every now and then, as anyone who has worked with robots in real life, we know that reality always shows us the edge cases and what's actually hard. So in this case, I want you to pay attention to the robot on the left. It's going to be picking up a yellow parcel, and you're going to see what happens when it tries to pick it up. So you see this oscillation that goes in there. That's something tricky to simulate. But it doesn't always happen. There are other objects similar to that one where this oscillation doesn't happen. So what do we really need from a simulator? If we're thinking, for example, about a perception algorithm, what we need from a simulator is for it to have colors and sizes and textures of the different objects that we want to simulate. If we're thinking, for example, about control, we may be more interested about the dynamic, the mass, and inertia. But we still have some simulation to reality gap. So some very clever engineers at Ocado ask themselves, what if? The question, what if? What if instead of learning in simulation, we learn in production, directly on the robots that are already doing their job, so that they get better at doing their job each time they do it. And in order to tell you about this story, I'm going to tell you about the last product that we have. So as I've told you, we have, we work with delivering groceries, we have this induction, and we also have a similar type of induction, but this is for apparel, so clothes, shoes, and anything that, we wear. So this machine is similar to the last one in the sense that there's a bunch of different products that come in at once, and then our robots have to do the same thing, identify different, in this case, clothing, pick them up, scan them, and then place them at different places. In this case, we have cubbies where the different clothes have to go. So I'm going to show you a little bit of how this looks. We have, the different products, t-shirts and sandals come in, The robots have to identify them, scan them, and then determine where they have to go and place them in the adequate cuts. So if we think about simulation in this case, we would think about, for example, deformable and transparent objects. Deformable, the t-shirts are deforming, and transparent because everything is placed in these transparent bags. So if you think about simulating this, this would be like a real challenge. The next thing that could be problematic is the scanner barcode detection. How can we really, mimic the behavior of the scanners? So given these challenges, our engineers thought, let's just try reinforcement learning in production. And what they came up with is something that we call RL scan. And this is only for the scanning part of the operation, of the induction operation. And what we do is that we have RL scan trains a closed loop control scanning policy. It trains it end-to-end training in production from a fleet of robots that are already doing this job. And it's able to achieve barcode scanning, and it's still improving because it continues to improve as it gains more experience doing this job. So in summary, simulations at Ocado, we use them to test the economic viability and develop products, test the different algorithms that we are developing. And a success story about this is how we used simulations in order to develop the powerful algorithms that power our Hive. We also use them to develop successful products with the help of simulations. However, we have found that there is a sim to real gap. And finally, we have innovated and gone beyond simulations and deployed RL in production with RL scan. At Ocado, we are very interested in being technology pioneers, powering the future of online grocery, and we are hiring. So if you would be interested in talking about different positions, if this is exciting for you, don't hesitate to talk to me at the end of this, during the lunchtime. Thank you so much.